Welcome here. Let's get started, Varsha.
Yeah. So welcome everyone. Uh, Before starting the webinar, I'd like to give a short intro about myself. So my name is Varsha Gupta and I'm a third year information science and engineering student at BMSC Bangalore. So I joined Cellstat in the month of November and I completed a 3-month internship where I learned different things like ML, machine learning, deep learning, computer vision. And I currently am working on a project called Cellbot. It is a project of Cellstat which called Cellbot. So this project is basically based on the medical sector. It's like a board for the medical sector that performs RAG on the research paper of archives and give the user information. So it's basically is very useful. So you can go and explore about it on the Imagine View platform of the Cellstrat. So the topic of the today presentation is Apple's large multimodal AI. So Apple's priority on devices might be the reason that we have not seen much from them in AI spaces, but it seems that it has changed. Like Apple launched its first multimodal on the 14th November of this year, showing that it's not behind from other companies in the race of LLM. So basically, Apple's researcher introduced MM1, their first large multimodal, which is capable of interpreting both image and text data. This model enhances capabilities in text in tasks such as image captioning and visual question answering. This model uh, this model utilizes 30 billion parameters for deep learning, and this model is also trained on diverse data set, like very vast data set, like 1 billion images and 30 trillion words. It's trained on that big source. And also this model can perform various NLP tasks, such as count object in the images, identify object within the images, and offer contextual information based on the everyday object. So this model it claims that it achieved top performance in benchmark against various other pre-existing AI models that we are going to see later in the presentation. So this model is designed for in-context learning. So there are basically two appealing properties that makes MM1 different from all other existing multimodals. They are in-context learning and multi-image reasoning. So, what is in-context learning? Can anyone tell me about in-context learning?
Yeah, that's
What
a
is,
broad term used for,
It's few shot learning.
yeah, basically, is we can think of it as a few shot learning. So basically, in-context learning is refers to the machine learning approach where knowledge gained from previous interaction is retained and then applied to the current situation. So basically, this allows pre-trained LLM to address new tasks without fine-tuning the model. So why first of all, why we require in-context learning? When we see in the supervised learning things, in supervised learning, we use something called back propagation. So in back propagation, we need to modify the model parameter, but that takes times. That takes times and that takes effort. So in this regard, in context learning does not update this does not work on the back propagation principle. It learns from the previous interaction, and this previous interaction is retained, and then when a user give some new tasks, then it's perfectly able to perform those tasks. We can think of it as a few shot learning, where the model learns from a few examples or even a single example provided in the prompt. So this in context learning uh, facilitate a more seamless and natural interaction between user and AI system by maintaining continuity and relevance in the conversation or tasks. So we see this how MM1 is able to perform in context learning through this figure. This figure given describes that MM1 can perform various tasks, such as it can count object in the images, it can perform OCR, it can demonstrate common sense and word knowledge, it can also perform basic math. If we see in the first row of the image, there's the teddy bear and a smartphone. So the user fit the image with the teddy bear and a smartphone, and the model is accurately able to give the response as there is a smartphone one and then a teddy bear one. In the second images, if we see there are three cats. So the figure contains three cats. So the model is accurately able to predict that there are three cats in the images. So this shows that the MM1 is perfectly able to count the object in the images. In the second row shows that uh, MM1 can perform OCR. So basically, there is a in first figure if we see here. So there is a signboard and there is something written. So the user want to know what's written there. So the model says that red circle, no parking anytime. I mean, it's able to read the text written on the board. So it can perform OCR very well. In the second example, if we see here, the model is able to read the text out of the out of the board, like Raffaello, and then after same in the second and third and the fourth images. This shows the OCR capabilities of MM1 model. In the third row, we see that the model is able to predict what there in picture, such as in the first picture we see here, we have a bed. So the model is able to not only give the information about the picture, but also about the frame and weight of the image. So model is giving the response like furniture bed, and the frame weight is 50 and 150 pounds, and gives an approximate weight of 23 to 68 kg. I mean, this bed can be approximately 23 to 68 kg. I mean, it's able to determine the weight also. In the last row shows that it can perform basic math functions. Like in the first image, if we see here, there is a piece of cake, and they written there's one symbol on it. And then the second image, there is some toy car, and there we have three written on it. So the model is like 1 plus 3 is equal to 4. So it's able to perform the math function by taking the numbers in the images. We normally do by text, but it can do math function by taking the numbers in the images.
So, Varsha, are you saying it is trained with chain of thought out of the
Yeah.
box?
Yes, sir. Yes, sir. It's coming in further. We are looking
Okay.
about this.
Okay.
So yes. So the second appealing properties is multi-image reasoning. So what is multi-image reasoning basically? So this multi-image reasoning is like we provide models with multiple images, two images and with two text, and the model is able to grasp the information and gives the answer according to that. So MM1 can navigate through multiple step reasoning process with few short chain of thought prompting. As I said about chain of thought, so what basically means chain of thought? Can anyone tell me what basically they understand by chain of thought? Chain
So
of thought.
large language model to reason.
Reason, yeah. Reason what kind of things?
Like when you're when you're prompting a question, or like when you're prompting a statement to make it understand from that particular statement.
Yeah. So yeah, basically right, that's right. So basically, chain of thought prompting is an approach that is used to improve the reasoning ability of the large language model in the sector called arithmetic reasoning, common sense, and symbolic reasoning tasks. If I give an example, suppose we give the chat GPT a prompt like take the first letter of the word called elephant and take the last letter of the word called forest and combine and give me the combined word of this. So if maybe the chat gpt might not be able to give the accurate answer most of the time, but if we give it a few short example take the first letter of the word elephant and the second letter of the word forest and combine it, so we give an example like the first letter of the word elephant is E and the last letter of the word forest is T. So and combining them we get ET, and we give another question on the top of it. Take the first letter of tiger and the second letter of cat and give me the combined answer of those letters. So now the chat gpt will perfectly give the answer because we made it to train using few short examples. So that is basically means it chain of thought prompting. We can use it to perform various uh, 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 tasks like mathematical reasoning or symbolic reasoning or any common sense of thing like that. So this ability is crucial for accurately answering question and solving problem that require understanding and analyzing multiple pieces of image simultaneously. Multiple pieces of image simultaneously, I mean more than one images at the same time. So this helps in that. We see here in this figure. In this figure, we see there are two images provided. So the user provided the model with the two images and asks a question like, how much should I pay for all the beer on the table according to the price on the menu? So we see here two images, image with a beer on the table and the another is a menu where there are different prices of the different stuffs. So if this user query, based on the user query, MM1 gives the response as 12, whereas other model gave it like MU chart is also a generative multi-model, and lava net is also a multi-model. LavaNet is basically it has achieved the state of art accuracy in the sectors related to science question and answering. So it is also a multimodal. So this two, so email chart give an answer of like 15.99, which is, if we see, which is not accurate. This answer is not accurate according to the menu price and the prices in the actual menu. And similarly, the lava net gives the answer as 44. So this answer is also not accurate according to the correct price. So the user asks the second prompt like explain why. So MM1 model is able to give the correct explanation like there are two beers on the table. We see the two beers on the table and each beer consists 6 according to the price on the menu. So 2 into 6 is equal to 12. So this is the correct explanation, and MM1 is able to give the correct reason with the correct pricing. Whereas other model like other emu chart which is trained on 37 billion parameter and the other lava net which is trained on 34 billion parameter, which is higher than the MM1 training data like 30 billion parameter, yet it is able to perform better than them in this regard, multi-image reasoning. So, as mentioned in the figure, as shown in the figure 1 and 2, we see that this model is able to has some appealing properties like in context prediction, multi-image, and chain of thought reasoning. So this shows that this design principle can be a competitive model at scale, and the AI Apple's MM1 teams they hope that this presented insight will remain relevant, even if if in the future they come with some modified component and data sources. So now we see the recipe for building MM1. So basically, what were the building blocks that helps to build the MM1? So there are basically three components: architecture, data, and training procedure. Architecture, we see how what components of the architecture impact the most, and then after what data sources were used and what training procedure were followed. We see in the sheet. Now, empirical setup for ablation. So what is meant by ablation? First, ablation is basically, it involves systematic ablation means it involves systematic removal or disabling a specific component of a neural network to understand their impact on performance. So first of all, to build the large language model, a small base configuration of the model was considered. So, and then on the top of this base configuration, systematic modification of a component at a time was done, and then the final recipe or final component of the model was prepared. So we start with the initial configuration. So the initial configuration contains the four components as we see there, like image encoder, vision language connector, pre-training data, and language model. So the first is image encoder. So image encoder is based on vision transformer technique architecture. It's like it uses a variant VIT L14, where L stands for large scale and 14 is the number of layers in the network. So this image encoder is trained on clip loss, and we on two different data sources like DFN 5 billion and VCAP 300 million. So clip is basically it is a clip stands for constructive language image pre-training, and it is a framework that learns joint representation of image and text. So in this scenario of image encoder, the model learns to associate images with their corresponding textual description, and the image of size 336 into 336 dimensions are passed as the input to the model. So in the second component, if we see, is visual language connector. So in the visual language connector, C abstractor with 144 image tokens was used. So basically C abstractor is it serves as a connector between the visual and textual informations, and this C abstractor enables joint understanding and reasoning across different multimodals like vision and language. The third thing we see is pre-training data. So during the training procedure of this model, a mixture of different data sources were
Hello.
used. Yeah,
Hello.
hi.
So can you explain the C abstractor more? I did not get what it does
Yeah, so C
and how
abstractor
it
is
does. Yeah.
yeah, I'll show you by a figure here. So we see this figure here. In this figure, we see that this is the architecture of decoder only LLM, where various components like image encoder, visual language connector, and text is used. So basically, this is the like we pass image. So the model is not able to read the image. We need to convert into encoder, encode the image. So for that, image encoder is required. Now we have, this is a multimodal, since we know this is a multimodal. So it is passed with image as well as the relevant text that describes the content of the image. And to connect this both thing, we need something that connects this both together and give a relevant meaning. So for that we use something called vision language connector. So vision language connector, we see here, vision language connector, we use C abstractor. So C abstractor is uh, basically it is a framework that helps to give the joint representation of image and text. Like we have passed the image and we have also passed the text. So this will relate the meaning of this text with this image and give a meaningful uh, way to the LLM to understand that yeah, this image is talking about this thing. So this makes
But
the multimodal.
hello. But don't we
Yeah, yeah.
have the image text probability distribution already in the clip? So why do we need the connector?
No, the image is there in the clip, but it's written only the like uh, name of the what is that product feature, like, but it's not clear. We need to provide the more clear what is the speciality of the multimodal, that it is able to read both image and text at the same time. So if we provide the model with the image and also the text that describes its content, so this will give the model more easier way to decode the user input. So for that, we need a connector, which
Okay.
is a visual language connector.
Thank you.
Yeah, welcome. So for image, we need to give image resolution should be good. That we need large images and multi-scale inputs. And the second is for encoder thing, we use image encoder pre-training. For image encoder pre-training, there are basically two things: constructive loss and reconstructive loss. So basically, what is constructive loss? So constructive loss and reconstructive loss are two things that is used to pretend the image encoder. So we see if the constructive loss is a framework that helps to that allows the model to learn from the given image scenarios, like if we provide. Hello. Hello.
Yeah, go ahead. Go ahead.
Yeah. So basically, constructive loss. I was telling about constructive loss. So constructive loss is a framework that encourages model to learn meaningful representation by emphasizing positive interaction between different components. If I give an example, like we in the image encoder thing, constructive loss encourages the model to learn features that capture object boundaries. So if we see in the images, this packet has a boundary, and this thing also has a boundary. So constructive loss helps the model to learn this boundaries and separations. And if we think in the text encoder thing, then this constructive loss promotes the model to learn meaningful word embedding and sentence embedding things. The second thing is reconstructive loss. So reconstructive loss is the basically the ability of the model to reconstruct the original input from its latent representation. So these two things are used in the image encoder pre-training. Now, if we see the vision language connector, there are basically three types of connector: average pooling, attention pooling, and C abstractor. So average pooling. Anyone know here about average pooling?
Varsha, one question is that do you have any mathematical representation of this constructor loss? From a mathematics point of view, how the boundaries are being calculated and how the separations of these boundaries, boundary of the packet and boundary of this bound, how these two looks like? Do you have any representation, or how we can understand that these two are separates and reconstructions is is the constructions of the original from that loss? Any representation or anything more complete with that?
Sorry, I can't hear you.
So there may be a
Could you repeat
mathematical
once?
formula because this presentation is based on the MM1 research paper by Apple researchers. So in the paper, we can find the mathematical formulas possibly for each of these, functions. See, essentially, clip was always there, right? Clip was a interpolator from text to image, image to text. But what Apple researchers have done to create a multimodal LLM, they have said, let's try something a more sophisticated, technique compared to clip to create a multimodal impact. So they have created, experimented, and come up with this the right side scheme to also feed the image intelligence into the decoder only LLM in addition to the textual intelligence, right? So they have played and come up with these neural network architecture, and the formulas for these losses and pooling, I'm sure, may be available in the research paper.
Yes,
The
so those
code
are
of
available in
the code has not yet been released, folks. So it is just
yeah,
a
it's not
paper.
publicly available yet.
And Vivek, one related question is that, so if we have a one representation for text and one representation for image, so then if we can join it to have a joint representation of image plus text, how that representation is different from multimodal representation, which again gives text and image together. So if manually someone gives, it is a text representation, it is image, combine them two, how much it is different from that? Any
See,
idea?
we don't know the very precise algorithm, right? It's just a paper, and they have chosen to, mention what they have decided. So here you can see that on the left they are feeding the text, and on the right they are feeding the equivalent image intelligence with some pre-processing, with the image encoder and connector type. So, beyond that, they have not provided details. So they are keeping some aspects under the hood, I'm assuming. Or, I mean, I haven't seen the paper. Maybe paper does have more details. You can check the paper.
I have a query. So this whatever they have described in text, this walnut and blue cheese, they have something described over here. So is this data generated from the text itself, or was it created completely independently? Like it was generated from the image, analyzing the image, or was
No,
it
no,
done
no.
independently?
It was done independently.
It was done independently.
Yeah,
So it was done independently by analyzing what?
by analyzing the picture scenario by the user.
So the user himself put in.
Yeah,
Uh,
himself put the text prompt.
okay, so what is the LLM doing?
So the LLM is basically based on the text and the image is able to it's like decode the things like it's perfectly able to perform like now if the user perform a rag on these things, then LLM will give the correct answer based on the both text and image.
So basically, will the LLM throw out an in-context learning sort of
Yeah,
answer? So
yeah,
not just detecting the image, whatever object is in the image, but also
image.
giving like a story sort of scenario for that. Like
Yeah,
so that, okay.
yeah, right.
Okay. So,
Exactly.
what makes that in-context learning happen is the advent of VL connector and image encoder. Is that what makes the speciality in this LLM?
In context learning, we sort thing. So we are already
Yeah.
providing two things, image and text.
Yeah.
So it's working like few short examples.
Okay. Okay. Fine.
So from what I can understand, it's like you're putting an image and you're also giving a prompt of what that image is. So
Yeah.
what query is there? Like if you're already fitting in what you can see from the image, you're doing that manually. Then what is this paper trying to get at? That is my query.
So we can perform other RAG on this. Like we can say what there inside the packet written in Fisher thing. So what there is
Oh,
inside the blue basket.
okay. All right. Yeah.
Yeah.
I think the paper gives pretty good description. Basically, image encoder is a vision transformer. They are saying, and
Yeah.
they are basically talking about multiple images. So they are correlating the text with the images. So it's not really much different from lots of other multimodal techniques which have been tried. And this is just Apple's way of doing it. And their
Uh,
researchers have
if
come
I'm
up.
not wrong, this is a direct competitor to Lava, right? Are they trying to achieve the same thing as what Lava does, in which you put in an image and then it gives a textual representation of the image?
Now, jog
Yes.
my memory. Lava is what? Lava is a image generator or image input?
You put in
Image,
an image and then you
image
get
input.
you put in the
But
image and you get the textual representation of the
yeah.
image.
But lava is basically it has achieved the state of art accuracy in related to science question and answering, related to science thing. But this MM1 is able to perform various things. We saw in the previous slide, like it's able to count the object and detect the object in the images, perform mathematical function, and with the chain of prompting it, and it can also do like reasoning and arithmetic tasks.
Yeah,
So
exactly.
we'll see.
That's
We'll
my
see the
question. Like, is it a
yeah.
competitor to Lava? Like,
Yeah. We'll see
are
that.
they trying to do what Lava does?
We'll see that in the next slide. I mean, there is a
Okay.
comparison between lava and other and this model.
All right. Okay. Thank you.
Yeah. So, any further question?
No, keep going.
Okay, sir. So in the right side, we see the modal ablation, and the left side, we see the data ablation. So in the data ablation, we see different types of data are used, like image, text data, interleaved data, synthetic data, and text-only data. So image text data is like caption data, where image with a caption, with a short text, which is more relevant to the image is used. And interleaved data is basically is the image with a diverse text related to the image, and which may be less relevant to the image. And the next is synthetic data, is the artificially generated data, and the text only data. So these various types of data were used in a different mixture, and this was used to pretend the MM1 model. And for the loss thing, it hyperparameter they train the hyperparameter to scale it further. So we see it in the model architecture ablation. So basically to do the model architecture, to perform the model architecture, we investigate on two things. So how to best pretend a visual encoder, and how to bridge the visual feature to the space of LLM. So there are four components that comes under this model architecture, which are image encoder pretending, encoder relation, vision language connector, and image resolution and connector relation. So image encoder pre-training is basically like clip pre-training image encoder was used for image encoder pre-training. So and the second thing is like encoder lesson, which is like image resolution has the highest impact, followed by the model size and training data composition. So this suggests that the image resolution has the highest impact, followed by the other things like model size and training composition. The third is like vision language connector and image resolution. So we saw in the above, in the previous slide in this figure, that for the connector vision language connector, different connector types was used, like average pooling, attention pooling, and C abstractor. So basically average pooling, what it does is, average pooling is a downsampling technique which is commonly used in neural networks. And if I give an example scenario such as like a feature map example, convolutional layer. So this average pooling, what it does is it divides this convolutional layer into non-overlapping regions and then compute the average value within each region. So average pooling is basically based on this principle. And the second is attention pooling. So attention pooling is it what it does is it allows neural network to focus on relevant part of the input data. It assigns something called weight to the different part of the data, like like uh, like like word in a sentence. If you pass the word in a sentence, so what is the most relevant word that should be like that is most important while pre-processing? And similarly, if we go to the image part of the things, so it provides weight to the certain region of the image which is more important for pre-processing. So attention pooling is basically works on focusing on the relevant part of the input data. And the C abstractor, C abstractor is basically it acts as a connector between the image and visual text and the language thing. And then after the connector, in the connector lesson, the number of visual tokens and image resolution matter most, while the type of visual connector has little effect. So this says that visual token and image resolution matter most. Whatever will be the type of visual language connector, however, it will have the little effect.
I had a question. So
Yeah.
you describe attention, right? So what
Yeah.
is attention pooling? Does it downsample attention values as well? Is it something like that? Because attention is attention, but what is attention pooling?
Attention pooling is like we are providing some weight to the input, whatever it may
Yes,
be
yes, I,
image.
I get that. I get what is attention, but what is attention pooling? Like, do you downsample the attention weight as well?
Uh, Downsampling, I doubt on that. But yeah, this is it's like providing relevant weight, and it is useful for NLP tasks such as machine translation, text summarization, for
Yeah.
those tasks.
Okay. Okay. Yeah.
Yeah. Uh, Now we see the pre-training data ablation. So to train this model, there are two stages: pre-training and instruction tuning. And to train the model, there are two types of data that is commonly used to train the multi-large language models. So captioning data and interleaved image text are the two types of data. So captioning data is basically that contains short text with high relevance, as I said earlier. And also interleaved data is like that contains diverse text with less relevance. So this, and also text only data was used so that it preserved the language understanding and capability of underlying pre-trained image. In the earlier slide we saw that uh, this image was passed and again this text was passed. So this helps to make the understanding of the model more clear, so that it can further process the user prompt. So, so from pre-training data ablation, there are four data lessons that they mentioned in the paper. So the first lesson was interleaved data. Interleaved data is instrumental for few shot and text only performance. So interleaved data is basically data which is a mixture of image and text. So this is instrumental for few text and text only performance. And also captioning data. So it is good for zero shot performance. And the second lesson is text only data helps with few shot and text only performance. Text only data, we know only the user text, only the text passing. So this helps with few shot and text only performance. The lesson 3 is the careful mixture of image and text can yield optimal model performance and retain a strong strong text performance. And the fourth is like synthetic data helps with few sort learning. Now, based on the previous result of the ablation, a final recipe for the MM1 model is prepared, which contains these three components like image encoder, vision language connector, and data. So for image encoder, we know that if we saw in the previous slide that image resolution is more important. So for that, we use the vision language translator with the variant H and image resolution of 378 into 378. Earlier in the base configuration, we saw that model image size was 336 into 336 plus 336. But later it's found that the image resolution is more important. So they increase the image resolution to 378. And again, the pre-trained with a clip objective. Clip is objective on DFN 5 billion dataset. And for vision language connector, we saw in the previous slide, the number of visual token is of more important. So vision language connector with 144 token was used, and the actual architecture seems to matter less. We opt for C abstractor. In data things, for a good model, we need to maintain both zero and few sort performance. So a different mixture of data source was used. We saw in the earlier slide like 45% interleaved image text and 45% text pair document and 10% text only document. So this compromises the final training recipe of the MM1, which was systematically modified and improved from the previous base configuration. So now comparing the MM1 with other pre-existing models. So the MM1 was evaluated on various benchmarks. Benchmarks like visual question answering, scientific and mathematical reasoning, and general multimodal understanding. So we see the comparison given in the table. In this table, we see the various benchmark like visual question answering, scientific and mathematical reasoning, and general model understanding. We see that the in visual question answering VAQ2, the model has excellent performance. Like it, MM1 science in the VQA visual question answering benchmark with an score of 83.7%, which is closely matching with the performance of Lava Net with 34 billion parameter, and also is significantly surpasses both Gemini models. We see here with 74.6 and 77.8, Gemini Pro and Gemini Ultra performance. So this demonstrates that MM1 is it's robust visual question answering capabilities. And the second, we see that also with text visual question answering. So MM1 stands out of all the models present there. Like there is no comparison of MM1 with in respect to the text visual question answering. It scores 81.0%. So which is a very good score, and it also shows that its unique strength in text and image comprehension tasks. And the science and math, in the science and math benchmark, MM1 shows commendable performance with a score of 44.7% with 8 short and sitting, and though with 44.7, Lava Net is has a score of 51.1% with 8 sub. So as I said earlier, like Lava Net is also a multimodal. It is a open source multimodal, but it has achieved the state of art performance in scientific question and answering. So we see the related to the science question and answering. Lava Net is a like winner. And also in the math vista, we see that MM1 zero sort score indicates that it has a strong mathematical reasoning with this Gemini Pro showing a slight edge. Like MM1 model is has a score of 39.4%, which is almost close to Gemini Pro, which is 45.2%.
Have you created this chart, or was it publicly available?
It's publicly available. It's there in the paper, but
Is it
exact the chart is not there. So I extracted it and made a table.
okay? So why are like, if you don't mind me asking, why are there so many empty spaces when it comes to lava and other models? Like, were
Because
these not benchmarked?
because in the paper I didn't found the comparison with these things.
All right.
The paper of MM1.
Okay.
Yeah. The last is general model understanding. In the so MM1 performance on MM bench and its adaptability in the wild scenario, as demonstrated in the lava bench we see. So it highlights that its general model understanding and application diversity is really good than the other existing models. So we see that in MM bench it has a score of 82.1%, and in seed bench it has a score of 72.1%, and similarly the lava bench it has a score of 87.6%, which is close to the lava next model. So we see through this benchmark in various scenarios, MM1 like leads the other existing multimodals, especially in this text visual question answering related.
How can we mention it leads other models if we don't have a comparison between other models?
I guess the comparison is, I mean, in the text visual question answering, might be the comparison not available for them. I mean, the publisher of the this Gemini Pro, they didn't mention any comparison in related to the text visual question answering. This is the data
No,
I got from paper. I mean,
my claim is that if you're saying in text visual answer questioning it is the best, then there has to be some comparison, right?
they didn't mention it, but I don't know.
I mean, it is from the paper, right? So,
Paper, yeah.
the paper link we have shared in chat. So if you read the paper, they have not given the code or further information. This MM1 paper was released, I think, within last 1 month.
Yeah, I mean the only question is that to make a comparison you need at least, like, two things to compare, right? So is text VQA something which they created themselves? Is that the reason why, like, is this benchmark created by themselves? Is that the reason why there is no data on it?
I
It can
think
be
this
just every
benchmark
component.
is basically for MM1 model, like because
Yeah.
it ticks
Yeah.
the boxes for all of the features that MM1 can do, but the other rest of the models are not doing any
Yeah.
of these.
Yeah.
So I
That's what.
think creating a comparison contrast for with respect to others with respect to MM1, I think would be a bad idea because you're not making a fair comparison there. I think
Yeah,
all of
yes.
these features are missing in GPT, Gemini Pro, and Gemini Ultra and Lava. So all of these features are only available in MM1, I believe.
Yeah, they wanted to show
Uh,
that there are
the
unique features in this sector. There might be that Gemini Pro and this Chat GPT be more good than this MM1 model, but being a publisher, they don't want to show like their incapability. They will show their good thing, right?
I mean, this is just a claim by Apple. Now, there is no neutral party validating this, right? These are Apple researchers who wrote this paper, and they are making these claims. Now, as to whether the claims are accurate, nobody knows. Some neutral party has to, and the MM1 is not even part of the Hugging Face leaderboard. A Hugging Face leaderboard seems to
Yeah.
track LLM performance, but MM1 has not even been released for anybody to benchmark it. The code is not available. So these are just claims by Apple. And by the way, since this paper came out, Apple has been making a flurry of GenAI announcements every week. So Apple is rapidly getting into it, and their stock price has in last 24 hours jumped by more than $100 billion because of their announcement that new Macs are coming, which are GenAI enabled. So Apple was lagging, and their stock has been lagging for the last 4 months, and suddenly the stock took a jump when they started making a flurry of and Tim Cook has announced in February that they are working very seriously on GenAI. So stay tuned for some interesting work from Apple.
I wanted to add something. The Text VQA benchmark is very old. It is something like 5 years old. So yeah, it is a general purpose benchmark.
All right. So okay. So this is not a benchmark which is created by Apple in that case, right?
No, it isn't.
Okay. Okay.
Okay, all right.
I mean, these figures are, a moving goalpost. In twice or thrice a week, this goalpost will shift.
But it is interesting that they don't even compare it with other models and just claim that their model is the best. Like yeah.
I think Apple is getting serious, so they are still tiptoeing into it. So let's see in coming months, we'll see a more serious play and
because I see this I see this in every other paper. The comparison is it's off. They don't compare it rigorously. They just claim that their model is the best.
Yeah, exactly. Like at least this is something which is a part of the research papers in advocacy, I guess. Like at least they could have even if the model is inferior, they should have made some kind of comparison if it is a general data set.
Yeah. So we see the performance and benchmark. So MM1 is really shows that it can do different things on based on the benchmark. So we see in the table that there are we have 3 models called GPT-4 with 10 billion parameter, Palm with 514 billion parameter, and MM1 with 30 billion parameter. So this model, all 3 models were compared in the three benchmarks like Glue score and then ImageNet accuracy and the code completion. So basically, Glue stand for general language understanding evaluation. So basically, it is a framework that tells how well a language model can understand the natural language. So it is related to the natural language understanding things. So in that scenario, if we see, then MM1 model has a score of 91.7%, which is higher than the GPT-4 and Palm model. Even though the GPT, even though the Palm model is trained with a 514 billion parameter, yet the MM1 leads in this Glue score, in natural understanding scenarios. And the second benchmark we see in the ImageNet accuracy. So ImageNet is basically is a diverse image data set which helps in the image recognition things. So in this scenario, if we see is, so the MM1 model has an accuracy of 82.4%, which is higher than again GPT-4 and Palm model. So that it shows that the MM1 model is 82.4% of the time it is right, which is really a good score. And for coming for writing code, it does the best job with a score of 87.9%, showing that it's really good at understanding and creating computer code. So looking on the table, we can see that MM1 is really leading in this all scenarios. And this is how fast the MM1 is performing. Like in the future, it can be a like a challenging to the chat GPT and Palm, other existing multimodals. So if we see the potential application and the use case of MM1, so we see that MM1 has a GLUE score of 91.7%. So GLUE score is related to the natural language understanding. So the potential application can be in the natural language understanding tasks such as text generation, language understanding, and summarization, translation, things like that. And also the second is image translation. You know that MM1 LLM is a multilingual capabilities. This allows to perform high quality machine translation between a wide range of variety of languages. So this can be used for global communication, localization, and breaking down language barriers in various industries and applications. The third scenario is content generation. So MM1 is able to understand the language correctly. So and it also is a multilingual capabilities. So in this regard, it can be a good content creation. It can perform a good content creation task, which is like writing text, report, or product description, and even creating pieces of stories and poems. And the last one we see is multimodal AI capabilities. So MM1 it can seamlessly integrate and process different types of data. Data we saw, various types of data was used, like image, text data, and caption data, synthetic data, and text only data. So, and it also has a good understanding of natural language processing. So all these things can make a very good multimodal AI applications, like a virtual assistant or autonomous system, or various other features. So if we see the key applications in the healthcare sector, so MM1 can be good at looking at medical images. So MM1 can check out the X-ray, MRI scans, and other medical picture to spot out the problem or diseases associated with it. And with this can help the doctor save both time and effort, so that they can look into the other important things uh, in the medical sector. And then after the keeping an eye on public health, so M1 can quickly go through the social media news and other places to find out the diseases of outbreak and see how they are spreading. In the corona time period, we saw that the preparation of vaccine medicine like it was not so fast. I mean, the doctor were unable to actually predict the symptoms of the corona, and so it was delayed in the preparation of the co-vaccine. So but if at that time, if we had something like this that can go through the social media and read the possible outbreaks of the diseases, so in this like this will be a great things. I mean, this will really can save much time and effort, and also it will be a faster. and also organizing patient record. So model can sort various doctor messy note and test results and other health record. So this will make it keep find and share important health information. In the second thing, if we see in the education sector, MMN can be used to make smart learning apps. Smart learning apps, like they can like app that is for the student to take test related to a subject matter. I mean, that will teach the student a subject like data structure, if we say. So in such scenario, this model can be used. Also helping with homework. We know that like since the chat GPT is released, like we student have got a lot of advantages out of it. Like we can generate, we can make a report of our project in a very short time. It helps to save the time. So so in this regard also, it can help to writing, and then after drawing, purpose like this, and also grading work. So MM1 can help grade assignment that include picture, writing, and more. So this will help the teacher to save time. And the last, if we see in the retail and e-commerce scenario, so finding what you like, I mean, can help in finding what it can suggest product by looking at the picture, what you read and what you do online. And talking to the customer is also another thing. We can make chatbot for more customer interactive scenario purpose, and also describing product pictures. So MM1 can write the description of the product picture, so people who can't see well can understand what being sold. So this makes shopping online easier for everyone. So now we see the limitation and challenges of the this model. So the first is bias and fairness. So we know that since this model is trained by using the data made by the people, so it might have choose some unfair biases, and which could sometimes be unfair. And so we need to do more checks to find out these biases and figure out how to make MM1 treat everyone equally. Also in interpretability, uh, like it's a mystery how MM1 decide what to do when it deals with different kinds of informations. So we have to we have to work on it to make it easier to understand how MM1 thinks and makes decisions. Data efficiency, like a number of data, a ton of data was used to train the model, but still the 30 billion parameter is still insufficient in comparison to training a large language model. We see that lava next was pretend using 514 billion parameter, though in some scenario it lags behind. So 30 billion parameter, I mean data, is still not sufficient to train a multimodal. So like more data, if we can train the MM1 using more data, and I mean that will be more efficient. Or and the model stability. So we know that MM1 is big and complex. So sometimes it might gives weird or unpredictable answers. So finding out the ways to make MM1 more reliable, like using a scores to show how sure it is, and is what something people working on it, like AI, I mean MM1 researchers. And the last is deployment challenge. So putting MM1 is not yet publicly available, and it is a big multi model. So putting it into the real use is really tricky, because it needs a lot of computing power, and also storage system. So figuring out how to make MM1 work smoothly and cheaply in the real world is a key for using it in the actual product and services. Now we see some qualitative examples where we see various scenarios where MM1 performed really well. It's like the first one is like example testing MM1 counting and OCR. So in this picture, we see in the first picture there are apples in the images, and the user asks gives a prompt like count the number of apples in the images. So the MM1 is able to respond like there are 7 apples in the images. Similarly, in the second one, the user asks the prompt like count the number of oranges in the images. So the model gives the response like there are 3 oranges in the images, which is correct according to the image. And also in the last row, it shows the MM1 OCR capabilities. Like an image is given, and then the user give the prompt like what are the scene text in the image. So the model gives the response like the earth without art is just which is written in the image. And similarly in the second picture, so this shows that MM1 can perform counting. I mean, it can detect object out of the text, out of the image, and also it can perform OCR things. In the second example, is like testing MM1 against adversarial prompt. So in the first image, we see that there is an image of the gray cat which is sitting on the couch. So the user asks the model like, can you find the red ball near the gray cat in the image? So we know that the red ball is not there. So still the user asks like, I mean, is there any red ball in the near the gray cat in the image? So the model responds like, no, there is no red ball near the gray cat in the image. The cat is sitting on a pillow on a couch, and there are no object like a red ball visible in the scene. So this shows that the model can perform well against adversarial prompt like this. In the second image, if we see that the user asks the questions like, can you see the bright blue feather on the bird's wing? So the model responds like, no, the bird in the image does not have a bright blue feather on its wing. The bird is a large bird of prey, such as hawk or an eagle, or with typical bird of prey features. So this shows that how MM1 can perform against adversarial prompt. In the third example, if we see that this MM1 is tested against image prompt alignment, like if we are passing an image, and the user asks the questions like from a scale of 1 to 10, decide how similar the image is to the text prompt, a parrot driving a car. So we know that in the image there is a dolphin, and the user asks the questions like upon the scale of 1 to 10, decide the similarity between the given image and the text prompt, like a parrot driving a car, and explain your reasoning. So the model responds like, I would rate the image as 1 on the scale of 1 to 10. So 1 is like lowest, the bad score. So in relation to the text prompt, a parrot driving a car, the image shows a dolphin swimming out of the water, and the text form is referring to a parrot driving a car. So there is no similarity between the image and the text prompt, other than the fact that the both contains animal. I mean, this shows that how well MM1 can perform against image prompt alignment. If we passed image something, and if we give the prompt that is not relevant to the image, the model can segregate the differences, can perfectly segregate the differences. Like in the first image, we see there is a dolphin which is swimming, and then the user give a different prompt which is not relevant to that, and ask the model to rate it in the score of 1 to 10. So the model rate it to 1, which is a very bad score. So it's like it's saying that no, the context, so the prompt provided and the image description is not similar. Similarly, in the second image also, if we see, it's the same thing. It's like from a scale of 1 to 10, decide how similar the image is to the text from a parrot driving a car. So it's like there is a parrot which is pretend like it's driving a car, and there is another parrot on the top of the car. So in this scenario, the model responds the image portray a scene that is quite similar to the text prompt, a parrot driving a car. In the image, there are 2 parrots situated inside a blue car, and the car is parked on a green field with a backdrop of palm tree and a yellow sky. So we see if we pass the image with a text prompt that is similar to the image, and if how the model performs, and also if we pass the text that is completely different from the image, so how the model performs. So in this both scenario, the model performs really accurately. Now then the fourth example, if we see testing MM1 ability to perceive image aesthetic. So it's like the user, there's a picture of an like out there is a picture of this air, I mean air this airplane, and then after the user asks the scenario, like after seeing the below image, how people might emotionally feel and react. So it's like the MM1 gives response like, upon witnessing the image, the people might feel a mixture of emotions such as a very fascinating and tranquility, the breathtaking view of the airplane window showing the wing of the plane, and the a vast snowy mountain range benefit. It offers a sense of scenery. I mean, it can it perfectly able to perceive the image aesthetic upon provided the text prompt. And the second scenario, we see a dark stare image, and the user asks like, after seeing the below image, how people might emotionally feel and react. So the moral response is like, the image shows a dark staircase with a creepy atmosphere which might evoke the feeling of unease, fear, or curiosity in the people. Some individual may react by avoiding the stairwell together. So it's like the MM1 is performing is perfectly able to perceive the image aesthetic when provided with the some user text prompt. The last and the second last example is like testing MM1 ability to compare multi images. So in the first image, we see there are two images given, one of the lake and one of the animals of the giraffe drinking water in the pond. So the user asks the questions like, for each of the two images, comment on whether the water is salty. So the model responds like, in the first image there are several boats floating on the body of water. So based on the presence of the boat, so this is a harbor, and the water is likely to be salty. And however, more and the second image, the various African animals including elephant and giraffes are gathering and drinking water. So the water is most likely fresh water, as animal need fresh water to drink. So we see how how accurately this model is able to compare the scenario between two images and give the correct responses. It's like giving two different things, and asking to compare these and give the accurate answers. In the second image, if we see, so there are two things like pizza, which is an unhealthy diet, and the second image we have a healthy diet. So the user asks like, which image shows the healthier meal. So the model response is like, the one with the pizza image is unhealthy, and the other with the broccoli and spinach is a healthier one. So this is how the model performs in its ability to compare multiple images. In the last example, if we see that M1 ability at reasoning across images and text. So it's like the user give the prompt like, I will show you several pictures and your task is to answer the question. So the first picture, if we see, so it's a beach picture. So, and then the second is like snow I mean, the picture that is related to the snow covered area. And the third is like, there are animals grazing on the green field, which is related to moderate climate, temperate climate. So the model gives the response like, the image with the umbrella on the beach, it's like 25 to 30 degrees Celsius, gives the temperature is like estimated temperature, and the umbrella is up, and the people are on the beach, suggesting a warm sunny day. And also in the second image, The model gives the responses like the temperature can be minus, is a snow area, and the temperature can be minus 20 to minus 30 degrees Celsius, and there are plane flying over the snow covered area, and there are vehicles on the ground. And also in the third image gives the response like the image with the animal grazing in the field. Also give the temperature like 15 to 20. So this shows that and provided the image itself, the MM1 can perfectly determine the scenario, and it is also able to give the temperature ranges that might fall between that might fall for this image things.
One question is that from theoretical point of view, what is the difference between reasoning and symbolic reasoning? Like in the previous picture, how a model can decide whether it should apply reasoning capability or symbolic reasoning capability. Any idea?
I can't hear you. Can you speak loudly?
Yeah. What is the difference of reasoning versus symbolic reasoning? How the model will decide whether it should apply
Yeah.
only a reasoning capability or symbolic reasoning, or aren't they both same? Something like
I can't hear you perfectly. Could you type in the text?
yeah. In that image, what is the difference between reasoning and symbolic reasoning?
But reasoning and symbolic reasoning.
Yeah. How the model will decide whether it should apply reasoning capability or symbolic reasoning capability.
That is not something. It was shown in the paper. This MM1 paper. They give this example. They claim that it's able to perform the symbolic reasoning things.
Vivek, do you have
They
any
didn't
perspective
provided
on this?
any scenario. Any informations about this able to perform the symbolic reasoning. They just claims that it performs the symbolic reasoning.
See, it's just a paper, right? So we are limited by whatever they disclose there. Now it's a
Yeah.
40-page paper, by the way, so it's very long paper. So
Okay. But in general, as a theory, like what is the meaning of symbolic reasoning? Any idea?
yeah, I have some idea because we had a course called Artificial General Intelligence, in which we had some lectures on symbolic reasoning. So symbolic reasoning means, let's say, a man is standing in front of car or behind the car. Understand? So a man is standing behind the car or in front of the car. So it would need symbolic reasoning capability, where a man is standing near the car, but you want to ask a question: is the car in front or man in front? We don't know, right? So that would need a symbolic reasoning. Or you may say, uh, let's say there are three balls, so and of three different color. So you'll say uh, which which of the two colors are closest to each other, right? Three balls of three different color. Which of the two colors are closest to each other? I think that would again amount to symbolic reasoning capability. So we are sort of beginning to venture into what we like to call as, neurosymbolic programming, which falls under the branch of artificial general intelligence. So it's getting there, but not yet fully there.
Yeah. Only one question is what is the part of the symbolic reasoning? Is this just identifying the image is called as symbol in the symbolic reasoning, or is it something different?
Yeah, I think it's that a visual intelligence, right, from that image. So a symbol, right, symbol, whether it's, let's say, uh, it's not image classification. There is reasoning, right? There is reasoning involved. So in the two examples I gave, there is reasoning involved. It's not just image classification. If I ask you a traffic signal is right turn or left turn, that's just image classification. But if I ask, uh, you know, uh, which of two cars is ahead in the race in a video, that will need symbolic reasoning probably, right? So I'm just answering generally. I don't recall exactly. We had actually a lecture on neurosymbolic programming in our AGI course, which Bhavesh had taught.
Okay. Okay, thanks.
Yeah, go ahead,
Okay.
Varsha.
Yeah.
We are almost here in the end.
So we are almost in the end. So now we see the conclusion in the future outlook. So we see that MM1 is a big step forward in making AI more smarter. So it uses 30 billion teeny pieces of data, and it can handle many type of tasks, from reading text to understanding images and writing code, and it makes us very flexible for different jobs. So also MM1, Apple trained MM1 in a very special way, that it launched from a mixture of practicing on its own and learning a specific tasks, like chain of thought prompting, and also in context learning. So it's really smart, and but yet it's not perfect. It might can sometimes make mistake, and make unfair biases. So and so in the various areas we saw, like healthcare, education, and online, how MM1 can be used. And also we can make it more reliable, and more reliable in the more they can make it more reliable in the near future. I mean, it's not publicly available yet, so they are just claiming these things, like they can perform all these tasks, but it's not publicly available, so we can't actually compare with other existing model. But it is a, I mean, great step by the Apple in the, I mean, uh, in the field of multimodal. So I hope that they will improve this, or and they will release it soon, so that we can test this on our own. So yeah, this was all about the Apple's large multimodals. Uh, so with this, I like to conclude my presentation, and thank you all for attending the webinar. And you can connect me through the LinkedIn. This is my QR code.
Okay, great presentation, Varsha. Very extensive discussion on MM1. So, folks, if you can imagine that, Apple controls the premium device ecosystem of the world with the iPhone and Mac. Now, if Apple decides to integrate, large language model or multimodal LLM into its device, on-prem, let's say on the iPhone or on the Mac or on the iPad, I mean, that will open up a whole plethora of thousands or tens of thousands of edge use cases. So because Apple does control the premium device ecosystem of the world, so that's why I think we are looking at a major revolution on edge artificial intelligence. If Apple is able to build these LLMs into the edge devices like Apple or iPhones or Macs and the watch and whatnot, right? So they pretty much control the premium device ecosystem of the world, and they have monopoly on that. So if LLM is integrated into an iPhone, you can imagine what will happen. It will open a whole plethora of edge applications. So definitely, long due from Apple, but I think they are slowly making some, headway into this. It looks very exciting what is about to come up, and how will OpenAI or anybody else keep up with Apple's distribution network, because Apple controls the hardware distribution network, right? So I believe Apple was negotiating with Google for the Gemini, and as well as with Baidu for China launch on the Apple Edge. Sorry, Baidu LLM. Yes, so Baidu LLM. So that alone, increased the stock price of Google when the rumor came out that Apple may integrate Gemini LLM in its devices. But I suppose Apple would want to have their own LLM and not give it away to Google. But anyway, lots of exciting innovations ahead. Any final questions for Varsha here before we close this session?
I mean, you mentioned right now that Apple is integrating Gemini for their main network, and I guess the reason, because even I came across that article, and the reason which they mentioned was something along the lines that right now their primary focus is not to create their own LLM when it comes to text data processing and all. So if that is the case, then why are they working so hard on this paper which we just saw right now?
I think Gauravaj, this is they are hedging their bets, right? Creating a LLM of the grade of GPT and Gemini, where years of research and billions of dollars have gone into it, and Apple really kind of didn't focus on it. Perhaps we are guessing.
Yeah.
So they are hedging their bets by also talking to, because OpenAI, Microsoft are more direct competitor to Apple. So they have a very large search deal with Google, right? If you use iPhone, the default search engine is Google search engine, right?
Yeah.
So and Google makes huge number of billions. Actually, Google gives billions to Apple for letting Google search be the default search on Apple devices. So Google gives billions to Apple, and Apple, that's a very lucrative business for Apple. So Google will now give many more billions if Gemini gets selected as the preferred LLM on Apple devices. So Apple is hedging their bet because they know technically it's not so easy to compete with Gemini and GPT sophistication. I think they are sort of hedging their bet both ways. But eventually, I believe Apple likes to control the stack, so they will make a play for their own LLM sooner or later.
Yeah, that's true. Yeah. I guess the current LLM is more focused on uh, processing images. That is what I got.
Well, this paper came out, with not such a big hoopla. In fact, some of the other announcements from Apple on GenAI are much more evident. This paper was released quietly. Nobody even talked about this paper in the research circuit. But people just picked it up, knowing that these are Apple researchers who published this.
Yeah, I mean, looking at the model performance, I can understand why they didn't put a hoogla.
I mean, they know this is not state of the art, right?
Yeah, exactly.
So
It's very, very subpar.
they're tiptoeing into it and sort of hedging their bets by also, playing OpenAI and Google against each other and saying who will give me more billions to make you my preferred LLM.
Yeah, true.
See, because nobody can surmount the Apple distribution capability. The fact with the millions of iPhones, and I mean, pretty much the top 1% of the global market of edge devices is controlled by Apple, and that's like the most lucrative hardware segment of business. So, any final questions, folks? But very interesting discussion on Apple's play in LLM. And I think we'll see a lot more of this, many more webinars on the Apple play in GenAI. Nice.
Sorry, I missed out on the discussion about Apple's LLM. What is the name of the LLM?
MM1.
MM1. Okay, MM1. Okay. So, what were you saying about MM1? Like, Apple is
No,
not.
they didn't make much hoopla about it. This paper came out a bit low profile.
Oh, okay.
People just picked it
But
up
it seems
because
to tick off all the boxes that she had mentioned today. Like the performance metrics was pretty impressive based on the.
I mean, those are claims made in the paper, but an independent agency has not verified if MM can outperform GPT-4 Vision or Gemini, right?
Okay.
Those are
But
just.
in terms of LLM, do you think GPT-4 is more advanced than MM1? And like whichever features that she had mentioned today, I don't think GPT-4 was there, right, as a comparison model.
No, it was there for some of the features like visual Q&A or basic Q&A. So I think GPT-4 Vision and Gemini are still state of the art for multimodal, and as per common benchmarks. Now Mistral and now Anthropic Claude 3 is claiming they have beaten all of those. So this depending on which day we talk, this discussion will change.
Right.
So, okay, folks. So, thank you all. So, in interest of time, let's close it. We do have another webinar in an hour or so. Thank you, Varsha. A lot of hard work and detailed deep dive into that paper. Appreciate that. And let's do some more webinars in future as well. Thank you, audience, for joining. And